Voyager has recently transmitted signals revealing that space is far from the quiet, calm void we once imagined. Instead, it is alive with surprising and powerful forces. After journeying more than 14 billion miles, Voyager 1 has crossed into interstellar space, uncovering intense magnetic fields and unusual energy waves. This breakthrough raises a profound question. Could it be that we have misunderstood the cosmos all along? Let's explore this monumental discovery and examine the evidence that points toward the presence of deadly alien forces. One of the most remarkable findings from Voyager's entry into interstellar space is the detection of a new magnetic field at the boundary between our solar system and the interstellar medium. Previously, scientists believed that the Sun's magnetic influence would weaken as Voyager passed the heliopause, the boundary marking the end of the Sun's domain. However, contrary to expectations, the spacecraft encountered a stronger and far more complex magnetic force. This discovery challenges the fundamental assumptions about the solar system's outer edges and the environment beyond, with implications extending beyond scientific curiosity. Understanding this magnetic field is vital not only for protecting Earth from cosmic radiation but also for envisioning the possibilities and dangers that future space travel may hold. Whether this newly found force presents opportunities or signals unknown threats remains an open question. Furthermore, Voyager's observations revealed an unexpected surge in cosmic rays, highly energetic particles associated with violent cosmic phenomena, such as supernova explosions. As the spacecraft ventured into interstellar space, the intensity of these cosmic rays spiked, suggesting that the solar system's protective magnetic shield, once thought to block much of this radiation, is weaker than anticipated. This discovery provokes troubling concerns. Are astronauts of the future prepared to face such elevated radiation levels? Could these cosmic rays be indicators of even greater, unseen dangers lurking in the depths of the universe? These findings emphasize how little is known about conditions outside our solar system and underscore the risks inherent in deep space exploration. Voyager's data also showed a turbulent interaction between magnetic fields and plasma at the heliopause, contradicting the long-held belief that this boundary would be smooth and predictable. Instead, the spacecraft's instruments detected strange fluctuations that defy existing scientific models. These irregularities may represent forces currently beyond our understanding, with potential consequences not only for space travel but also for Earth's safety. As space agencies like NASA and private companies such as SpaceX prepare for missions to Mars and beyond, these revelations demand a thorough reassessment of how humanity approaches interstellar travel. For decades, Voyager has symbolized human ingenuity and the spirit of exploration. Its unexpected discoveries highlight not only the spacecraft's incredible durability, but also the brilliance of the scientists who designed it. Even at such immense distances, where signals take nearly a day to reach Earth, Voyager continues to relay invaluable information. This ongoing success speaks to the meticulous planning and engineering behind the mission. However, with the spacecraft's power reserves diminishing, there is growing concern about how much longer Voyager can continue to operate. If it ceases functioning soon, we may face a critical gap in our knowledge about interstellar space. Despite these challenges, Voyager's findings have the potential to revolutionize our understanding of the universe. The anomalies detected, from fluctuating magnetic fields to unexpected radiation levels, could hold clues to developing new propulsion techniques or protective technologies. These advances might pave the way for safer, more ambitious space exploration. At the same time, these discoveries compel us to confront the harsh realities of deep space. What if these forces are not merely phenomena to study but active threats to human survival beyond Earth? How do we balance the human drive for exploration with the imperative for safety? The rise in cosmic ray intensity near the heliopause is not just a concern for astronauts venturing into space. It has broader implications for life on Earth. Increased radiation levels could interfere with satellite operations, GPS networks, and global communications. Imagine a world where essential technologies that society depends on daily become unreliable due to deep space forces. This risk highlights the profound interconnectedness of space and Earth, and the urgent need for comprehensive strategies to mitigate these dangers. Ethically, these revelations raise significant questions. Should humanity continue to push the boundaries of space exploration when the associated dangers remain poorly understood? What responsibilities do we have toward astronauts who will face these risks? Voyager's journey also challenges our understanding of the interstellar medium, the matter and energy that fill the space between stars. The spacecraft's instruments have detected irregularities in how the solar wind interacts with cosmic dust, hinting at forces never before encountered. Could these be remnants of ancient cosmic events or entirely new phenomena? The answers to these questions could reshape our understanding of the universe's structure and history, but also bring greater uncertainty. If these forces prove more dangerous than anticipated, they could jeopardize future missions to the Moon, Mars, and beyond. However, this is not a tale solely of doom. Voyager's data could help scientists develop technologies to reduce these risks. For instance, a better understanding of cosmic rays and magnetic fields might lead to innovations in spacecraft shielding and radiation protection, making long-term space travel safer and more feasible. Studying these forces might even reveal new propulsion methods that allow spacecraft to travel farther and faster. In this sense, Voyager's discoveries represent both a warning and an opportunity. The urgency of these revelations cannot be overstated. As private space ventures and national agencies ramp up ambitious projects, from SpaceX's push toward Mars colonization to NASA's Artemis program aiming to return humans to the Moon, it is critical to account for the harsh realities exposed by Voyager. The stakes are enormous. Failure to address these challenges could result in catastrophic consequences for space exploration and life on Earth. The Voyager missions remind us that exploration comes with both risks and rewards. Their findings challenge humanity to think bigger, adapt faster, and prepare better. As we stand on the brink of a new era of space exploration, Voyager's legacy serves both as a guide and a caution. The universe is vast, unpredictable, and full of wonders, but it is also a place of immense danger. The question is not whether we will continue to explore, but how we will ensure that exploration benefits all of humanity. Voyager's greatest contribution may lie not only in the data it has sent, but in the profound questions it forces us to ask. What else is out there, waiting to be discovered? Are we ready to face the challenges that venturing into the unknown will bring? And perhaps, most importantly, how can we use this knowledge to secure a better future for Earth and beyond? The answers will shape the next chapter of human history, a chapter written among the stars. Reflecting on what Voyager found also invites us to consider humanity's earliest steps in space exploration and what was learned along the way. For, as long as humans have existed, we have gazed up at the stars, wondering what lies beyond. For much of history, however, these were only guesses. It was not until the 20th century that technology provided the tools to truly venture beyond our planet. Rockets, massive, roaring machines, made it possible to break free from Earth's gravitational pull and enter the vast cosmos. A pivotal moment came in 1957 when the Soviet Union launched Sputnik 1. Though it was just a small metal sphere emitting simple beeps as it orbited Earth, this achievement shocked the world. It was humanity's first proof that we could place objects in space, opening the floodgates to exploration. 4 years later, Soviet cosmonaut Yuri Gagarin became the first human to orbit Earth, completing his journey in 108 minutes, a trip that changed everything. Suddenly, humans were no longer mere observers of the stars, but participants in the vast universe. The United States soon entered the space race. In 1961, Alan Shepard became the first American in space, albeit on a brief, 15-minute flight. The following year, John Glenn orbited Earth 3 times, demonstrating America's serious commitment to space exploration through NASA's Mercury program. These missions focused on testing human ability to survive and function in space, and they proved that humans could indeed handle the challenge. The rivalry between the Soviet Union and the United States propelled space exploration to unprecedented heights. In 1963, Valentina Tereshkova became the first woman to orbit Earth, spending 3 days and circling the planet 48 times. This milestone was significant not only for the Soviet Union, but also for women's role in space. The most iconic moment of this era came in 1969 when NASA's Apollo 11 mission successfully landed astronauts on the Moon. Neil Armstrong's famous words, "That's one small step for man, one giant leap for mankind," were broadcast worldwide. This was not just a moon landing. It was a declaration that humanity could dream bigger than ever before.